Hi kids, in today's video we'll discuss motion in one dimension from class 9 physics. Now in our previous class on measurement and experimentation we did what is physical quantity. Now we know what is physical quantity. Any quantity which we can measure, जिसे हम measure कर सकते हैं उसी को physical quantity बोलते हैं. Now physical quantity again can be divided into two types. One is scalar quantity and the other is vector quantity. Now ये scalar quantity क्या होता है और vector quantity क्या होता है? Quantities which can be expressed by magnitude is known as scalar quantity, and vector quantity, quantities which can be expressed by magnitude as well as direction. They need one more parameter. They need as well as direction. Then those type of quantities are known as vector quantity. Over here there is one parameter which is magnitude. Again magnitude, we can say, suppose mass, we have 5 kg of mass, and this is a complete statement, because as soon as we hear 5 kg of mass we know what we are measuring. Okay, how we are measuring. This is a complete statement. Isn't it? This, if you look carefully, has two parameters. Has a numerical value which is 5 and a unit which is kg. And this is enough to express mass. But suppose I'll tell you from here, suppose there is a body A, you need to displace the body by 5 meter. I'll tell you, displace the body A by 5 meter. Now this is an incomplete statement, because you can displace it in all the possible direction. Okay, but if I tell you, so this is incomplete, we don't know where to displace the body. But if I tell you displace the body by 5 meter due east, now it has a proper sense. Now we know that if the body is over here, we need to displace the body due east 5 meter. So this kind of quantity which is displacement over here, we are talking about displacement, always has a direction. Force, pressure, they always have a direction. So they are known as your vector quantity, like force, pressure, displacement, velocity, displacement, then velocity. These are all your vector quantity. They have, how many parameters are there? Suppose they have a numerical value 5 Newton. Okay, numerical value. Of course they have a unit as well as they have a direction. Look over here, 5 meter due east. You have a numerical value, you have a unit, and you have a direction. So that is your vector quantity. Scalar quantity only has magnitude. There is no need of direction. Without direction only the meaning is understood. We have speed, we have distance. Don't confuse yourself with distance and displacement. These two are two different things. Speed, distance, time, these are all your scalar quantity. They need only one parameter, that is numerical value and unit. Now look over here. Scalar quantity, remember, scalar quantity follows law of algebra. So you can add them, you can subtract them, multiply, divide, whatever, using the law of algebra which we are studying. But when it comes to vector quantity, they don't follow algebraic law. They have separate law which we will of course study in class 11, 12. Vector law of addition or subtraction. They follow that law. Am I clear? Now when we talk about scalar quantity, if you want to represent speed, we write it as S. Displacement, suppose you write it as D. This is the representation. But when you write a vector quantity, suppose you write force. So it's like force and a small arrow on the top. This is the representation for vector quantity. Velocity, this is the representation for velocity. A arrow at the top represents a vector quantity. One more thing. The negative sign with a vector quantity implies opposite or reverse direction. What do I mean by this? Suppose there is a force which is applied in this direction, F. Then what is minus F? Minus F is a force of same magnitude but applied in a opposite direction. This is your minus F. Clear? Now we look at rest and motion. Rest and motion. When do you say that the body is at rest? When the body does not change its position with respect to its immediate surrounding, then we say that the body is at rest. For example, this whiteboard is not changing its position with respect to the surrounding, isn't it? When I see this blackboard, it's not changing its position. So we can say that this whiteboard is at rest. And when do we say that the body is at motion? Definitely the body changes its position with respect to its immediate surrounding. Then we say that the body is at motion. For example, when I see a car moving, I see that it changes its position with respect to the immediate surrounding. Then we say that the car is at motion. Am I clear? Now, one thing we have done earlier, that nothing is at absolute rest. Everything is moving. Why? Because suppose this is your earth. Okay, you have a tree over here. So when you see this tree, you can say that the tree is at rest, because with respect to the surrounding, immediate surrounding, the tree is not changing its position. But a larger picture, the earth is rotating as well as revolving, which means the position of the earth is changing, which means definitely the position of the tree is also changing, which means the tree is at motion. But we can say that the tree is at rest with respect to the immediate surrounding. So I hope what is rest and motion clear. Now, in this chapter, we'll be studying the description of motion of a body, and we assume the body to be point particle. जो भी बॉडी यहाँ पे assume कर रहे हैं हम लोग मोशन, वो पॉइंट पार्टिकल है. Now the question arises, very big question, what is point particle? नाम से ऐसा लग रहा है कि जो बहुत छोटा होगा उसी को पॉइंट पार्टिकल कहेंगे, बट ऐसा कुछ नहीं है, सब धोखा है. लोगों भैया, whether an object is considered to be point particle or not depends on the distance it covers. If the body covers a large distance as compared to its dimension, to its length or dimension, whatever you say, then we assume the body to be point particle. अगर एक बॉडी बहुत ही ज्यादा डिस्टेंस कवर करता है एज कंपेयर टू द साइज ऑफ द बॉडी, तो उसको हम लोग पॉइंट पार्टिकल कहते हैं. फॉर एग्जांपल, अगर एक ट्रेन स्टार्ट होती है सपोज कश्मीर से और कन्याकुमारी जाती है, सो इट कवर्स अ ह्यूज डिस्टेंस एज कंपेयर टू द साइज ऑफ द ट्रेन. सो इन दैट केस योर ट्रेन इज योर पॉइंट पार्टिकल. Look carefully. The earth revolves around the sun and covers a huge distance as compared to the dimension of the earth, which means the earth can also be assumed as a point particle. So whether you take an object to be point particle or not depends on the distance it covers. Suppose a train starts and stops after 200 meter, then you cannot tell that the train is a point particle, because the distance which it covers with respect to its length is not too much. Am I clear? Now, so in physics we are dealing with point particle. Remember that in this chapter mainly it's point particle. Now, motion in one dimension. Just look over here. We'll be studying motion in one dimension, and the object is your point particle. Now, what is motion in one dimension? Oops. This is your motion in one dimension. When a body moves, in a straight line, then we say that the motion is in one dimension, which means the motion of the body can be represented either by the x-axis or by the y-axis alone. For example, when this marker fell down, the motion of this marker can be represented by the y-axis at different time. Where was this marker? Suppose a train is moving in a straight path, then the motion of the train can be traced with the help of x-axis, isn't it? Suppose as x at t equals to 0, the distance covered was, of course, it starts 0 meter. Then at t equals to suppose 2 seconds, it goes 10 meter. Suppose at t equals to 4 seconds, it goes to suppose 20 meter. So like this you can express the motion of the train either by the x-axis. You can express the motion in one dimension either by the x-axis or by the y-axis. You don't need both the axes. When a train is moving, you need only the x-axis. When something falls, you need only one axis, which is y-axis, to describe its motion. So that is your motion in one dimension, when the body moves in a straight line. Then the question arises, there must be motion in 2 dimension. Yes, there is. Motion in 3 dimension. Yes, there is. Look over here. I'll just rub this part. Just look over here. This was motion in 1D, one dimension. Suppose, which means the position of the object can be, you can get the position with the help of x-axis or y-axis. But come on, there's a situation when you over here, your friend over here, you throw a ball, it covers this path. You throw a ball to your friend, covers this path. Now, the motion of a body in a plane, motion of a body in a plane is motion in 2 dimension, because the position of the ball can be represented with the help of x-axis as well as y-axis. You need both the axes to represent its position or to represent its motion. That is your 2D, motion in 2 dimension. And what is motion in 3 dimension? You know, 3 dimension. Over here you have either x-axis or y-axis. You have x-y axis both. Motion in 3 dimension, you have x-axis, y-axis and z-axis. You have 3 axes. Suppose the motion of an aeroplane, or motion of a bird. When a body moves in space, when a body moves in space, then we say that the motion is 3-dimensional, because the position of the body can be represented with the help of x, y and z axis. You need 3 axes to represent the motion. That is your motion in 3 dimension. Okay. Now look at distance and displacement. Distance. When I talk about distance, I mean the path traveled, the length of the path, the length of the path traveled by an object is known as the distance covered by that object. But when you talk about displacement, the shortest distance between the initial and final position of the body, final position of a body is known as displacement. For example, suppose you are at A, you want to reach at B. Now you go like this. So this is the distance traveled by you. But if I ask you what is the displacement, this is your displacement from A to B. The shortest path is your displacement. Displacement is a vector quantity. So it depends, it has magnitude plus direction. But when you talk about speed, when you talk about distance, it's a scalar quantity, which means it has only magnitude, no direction. How do we get the direction of displacement? It's from initial to the final. This direction, from A to B, that is the direction of the displacement. If you look carefully, distance depends on the path you travel. Depends on the path traveled by the body. But when you talk about displacement, it does not depend on the path traveled by the body, because it's always from the initial to the final. That shortest distance is your displacement. How you're moving doesn't matter. Next, just look over here. So the next one, just look over here. The magnitude of displacement will be either equal or less than the distance. What do I mean by this? Just look at this scenario. Over here only, if you see, the path traveled by the body is this path, the blue one, which is more as compared to AB, isn't it? Take one more example. Suppose this is your A, B, C, it's a right angle triangle. The body starts from A, reaches to B, this is 3 meter. From B it goes to C, 4 meter. So if I ask distance, that's 3 plus 4, 7 meter. But the displacement is from the initial to the final position. And this is your direction. And we know AC is the hypotenuse, which will be 5 centimeter if this is a right angle triangle. Then your displacement is 5 meter, not centimeter, 5 meter. See, the displacement is less compared to the distance. Am I clear? Take another scenario. Suppose from A to B, you travel this path only, then the distance as well as the displacement is same. So the magnitude of the displacement will be either equal or less than the distance. Next, distance can't be negative, but displacement can be negative. How? Because we have done displacement depends on the magnitude as well as the direction, and the negative sign denotes reverse direction. So displacement negative is possible. Okay, negative sign denotes reverse or opposite direction. Suppose you move from A to B, okay, then AB is a positive displacement. But when you talk about if the person moves from B to A, then it will be negative. The direction reverses. So the vector quantity becomes negative. Am I clear? Now next, displacement can be zero even if distance is not zero. Now what is this scenario? Which means distance is not zero but the displacement is zero. Very easy. Suppose a body moves in a circular path. It starts from A and then comes to A only. Then the distance traveled, suppose this is R, the distance traveled is 2 pi r, but the displacement is 0 because the initial position and the final position is same. Similarly, if you throw a body vertically up to a height of h, then again it returns back, isn't it, to the same point A. In this scenario also, the distance is 2h, but the displacement is 0. The initial and the final position is same. Clear? So these were the differences you can see between distance and displacement. Unit we know. Distance, the SI unit is meter. The CGS unit is centimeter. Same for displacement. SI unit is meter and CGS is centimeter. So in this video, keep it till here. In the next video, we'll see the next part. Till then, take care and be safe.